I'm one of those die-hard office hour guys, right?
You certainly are, Michael. Okay. So welcome. I am going to bring up my tablet, and then you guys can see what I'm writing here. Hopefully, everyone got a chance to take a look at the enrichment problem that I had posed, and the second enrichment problem of the week, I believe, looked something like this. Is that right?
Yeah.
Yeah.
Okay. So did anyone come up with any strategies to solve this, to find that shaded area?
Didn't we like find the shaded area already?
We've done a problem similar to this, but
Was it with 3 circles?
it was with 3 circles. It was with 3 circles, and it was to find the area in between the 3 circles. But this time I have 5 circles, and one of them overlaps all 4 of them. Okay, that's the situation right now. So whenever you don't know something in geometry, it is always it's a strategy to draw all over it. Okay, so what do I mean by drawing all over it? Well, let's draw in some lines, okay, that may potentially be helpful. Okay, our goal is to figure out what those shaded regions are. I've also described that that box, that quadrilateral, right? What kind of shape is that? ABCD.
The square.
It's a square. Okay. I've also described that
Square.
the radius of each one of these circles, including the one including circle E, right, has a radius measuring r, right? So each of these are r. So these are all squares, right? It's a square, okay, and the side length of the square has 2r. What I'm going to do is draw in this line here, like so. And hopefully, maybe we can get something out of that. Yeah,
A
second
second
square. And just to emphasize that this is actually not there, right? It's a construction that that we are putting in, okay, hopefully to help us out, okay? And something else that I want to emphasize, can it be agreed upon that the shaded region over here that I am highlighting in green, okay, is this the same as the shaded region that I am highlighting in yellow? Is that the same?
Yeah.
Are the same, right? They're reflections of one another. So theoretically, if I can find the area of one of those or half of those shaded region, all I got to do then is to multiply that by 8, then, right? Because that's how many of those half shaded regions I have. So that's my intention, okay, for the next couple minutes, and it's just as easy as that. So what strategies do we have to figuring this out? Well, let's say my intention right now is to figure out what this guy is right here, right? And wait a minute. What is the measure of the intercepted arc here? What is the angle measure of the intercepted arc over here?
90.
Say that again, Sasha.
90.
It is indeed 90. Okay. So why is that going to be helpful? Well, it's going to be helpful because what I'm going to do is I'm going to focus my attention right now, okay, on just that little corner piece, okay? I'm going to focus my attention on just that corner piece. So my intention is to find out this area that's shaded right now that looks like it's green there, right? that half shaded region there, okay? But before I get there, okay, I'm going to find out what is the area of this sector. This is something that we had talked about last week, remember? Right? The area of the sector. So if the radius here is r, has a length of r, how do I find out the area of the sector? What is that? Anyone have any ideas?
The central angle, or
You could do 1/4
Yeah, this is
pi
just
r
going to be a
squared.
quarter of it. Okay, this is indeed 1/4 pi r squared. Right? That's a quarter of a circle. Right? That's a logical way of thinking about it. Another way of doing it, right, Sasha? Because I think you were hinting at using a formula, right? The formula, right, was theta pi over 180, right? That tells us the proportion, right, for the central angle. But we're going to multiply that by 1/2 r squared, right? And we'll end up in this. We'll end up in the same place. Okay. Whoops. But again, don't ever lose your sense of logic, your sense of like common sense. That's a quarter of a circle. Rather than using fancy formulas, okay, this is something simple enough where we don't have to use fancy formulas. That's a quarter of a circle. Why is that important? Well, I can now transition to looking at the circle just slightly differently. Why don't I take another moment and try to figure out what this area is? Why is that important? What do you think I'm trying to get at here? Why am I trying to find the area of that triangle then? Again, this is...
because then subtract that, and then you would have that like 1/2.
Yeah, that's all it is, right? So again, when the trick, okay, behind this problem is, you know, drawing things inside of the diagram to provide other information that wasn't there before. Okay, so that's what we did. So this triangle over here will have an area of 1/2 r squared. Okay, because both the height and the base, okay, of this triangle are r. Okay. All right. So the area of this, just that alone, right? Just that piece alone. Whoops. The area of just this guy right here. It will be 1/4 pi r squared minus 1/2 r squared. Okay. I'm gonna try to clean this up a little bit. Okay, you don't have to actually, you know, continue with this, because this guy right here, that the thing that I just wrote, this thing is in fact the area of half of that, right? So I could actually just take that 1/4. Whoops. I could just take that 1/4 pi r squared minus 1/2 r squared and multiply that by how much?
8.
By 8. But I want to do a little bit of simplification just to make the answer look a little nicer. Okay, so I can, what I'm allowed to do right now, if you look at this, I can distribute the 8, right? And if I distribute the 8, I'm going to be left with 2 pi r squared minus
Minus
4 r squared. That's right. Okay, so I'm going to be left with that. And just to make it look yet a little nicer, if you look at the this last thing that I wrote, is there a common factor between 2 pi r squared and 4 r squared?
R squared.
R squared, that's right. Okay, so I'm going to separate out the variables that way. And what I'll end up with is r squared times 2 pi minus 4. That's all it is. That's our final answer there. And it looks really nice, neat, and compact, right? That's all it is. Did you guys think of when you guys thought of this problem, what strategies did you guys come up with?
I have no idea what to do.
Well, these ideas come with experience, right? And the more of these types of like enrichment problems that you try, okay, the better, more confident you will be. I would say this problem here, it's more on the line of um, like an SAT problem because it's like very much like logic based. Um, but definitely like one of the last questions on the SAT, I would say. Okay. Cool. You guys have any questions for me?
Not about this.
Okay, I want to stop recording and then